Algebra 2, Unit 7, Lesson 4, and in this lesson we're going to talk more about graphing vertex form. Now, we've learned over several different units or sections that y equals a times x minus h squared plus k is your vertex form. Your h and k are the vertex. The h value tells you whether to move right or left. The k value tells you whether to move up and down for your vertex, so it tells you where the vertex will be in relation to where the origin is in the parent function. And your a value tells you whether the function opens up or opens down, tells you how wide or how narrow the function will be. So in this one, we have y equals -2 times x plus 4 squared minus 3. So in this one, I know that my vertex is going to be -4, -3. So from the origin, I will go left 4, down 3 to get my vertex. And then I know since this is a negative, it's going to open down. So what that means is, if I just go over here and graph this, -4, -3 is my vertex. And we know that this function is going down. So I know right off the bat when I graph that vertex that it's going to go down. So what that means is both of my roots are going to be imaginary numbers because it never actually crosses the x-axis. Another important thing to understand with that -2 is that the graph is going to be a little bit more narrow than your normal y equals x squared parent function graph. And if they were to ask me to graph this, there are a couple different things I could do. Normally I would try to find the roots, but if I can't find any roots, if they're imaginary, that's not really going to help me. But I do know that since this parabola has a vertex of -4, -3, I know that the axis of symmetry comes down through that vertex. So I know that if I find some ordered pairs on this side of the parabola, I can just use symmetry to find some on the other side. And normally, when I tell my students to graph parabolas, I ask them to get at least 5 points. So there are a couple ways you could do this. You could get this in standard form if you want. And if you get it in standard form, that would give you what the y-intercept is. But in this case, since we don't really know how far down that y-intercept is, and our graph only goes to -10, that might not be the best practice to do. So what I'm going to do is I'm just going to do a little XY chart, and I'm just going to choose a couple of numbers that are really close to -4. And I'm going to choose whole numbers so that my answers are a little bit more manageable. So I'm going to try -3, and I'm going to try -2. You don't want to try numbers that are too big because remember, our graph only goes from 10 to -10. So if we choose numbers that are too large, it's not going to fit on the graph. So if I try -3 and -2 and plug those in. Now the good thing is you can use Desmos to do this. You can use your calculator to do this. However you want to generate these ordered pairs is fine. You do not have to do it in your head. If I plug -3 in, -3 plus 4 is 1, 1 squared is 1, 1 times -2 is -2, and -2 minus 3 is -5. So that gives me the ordered pair of -3, -5. If I plug -2 in, -2 plus 4 is 2, 2 squared is 4, 4 times -2 is -8, -8 minus 3 is -11. So that gives me some ordered pairs. -3, -5 is right here. So for the -2, -11, I'm kind of going to guesstimate where that would be. My graph only goes down to -10, but if I go just a little bit past -10, that's close enough. And then I'm going to extend my axis of symmetry here. And so I'm going to use symmetry. I know my parabola has to be symmetrical about the axis of symmetry. Incidentally, that axis of symmetry, it is going to be important that you understand what the equation for that axis of symmetry is. And to get the equation for the axis of symmetry in these parabolas, what you have to do is look at the vertex. The axis of symmetry will always be the vertical line that is associated with that point that goes through the vertex, or that point that is the vertex. So this is my x value of my vertex. So the equation of that vertical line, remember a vertical line equation is x equals a number. So the equation for my axis of symmetry, and this is something that is going to be asked, I don't know if it's in your homework tonight or another night, but you will get there. The axis of symmetry here is x equals -4. So that's something that they might ask you to find eventually. So x equals -4 is my axis of symmetry. It helps me determine, like my vertex will be on the axis of symmetry, and then I can use symmetry with the other 2 points that I found. So that's 1 from the axis of symmetry, 1 on the other side would be here. That one is 2 from the axis of symmetry, 2 on the other side would be here. And that gives me enough points, because they're always going to ask us to do 5 ordered pairs, to give a good estimate of where that parabola would be drawn. And understand, you can do this on your computer in Desmos. You do not have to be able to draw it by hand every time. As long as you can find the ordered pairs, you can then click in Desmos where you want to generate that parabola. So don't feel like you have to draw the graph and all that. Do it on Desmos, because that's going to give you a better understanding and a better visual of what that parabola actually looks like. So we're going to talk about the basics, like this one has 2 complex roots. The axis of symmetry helps us to divide that parabola in half, and we can use symmetry to find other points on the line, so that we really only have to find the vertex and 2 other points. Then we can use symmetry to get the other 2 points. I would always make sure that when I'm plugging into an equation to get the ordered pairs, that I try to pick points on both, or on the same side of the vertex. So this is on the right side of where the vertex was, so that I can use symmetry for both of those points. A problem that I see some students doing, they would pick -3 and get -5, and then they would pick the -5 and get -5, and that doesn't help them with the 5 ordered pairs. We need 5 ordered pairs to generate our graph accurately. So that would only be 3, so then they have to do it again, and they're plugging in 1 extra time. So I always try to make sure the x values that I'm plugging in are either on the right side or the left side of my vertex. It makes it a lot easier. Here is another equation. This one's in standard form. So when I have an equation in standard form, the first thing I always do is I factor it so that I can find the roots, and I see what happens, or I see if it's capable of being factored. If it's not, then I'm going to use a different method. So 2 times 9 is 18. Are there factors of 18 that add to give you 8? So let's see, 18 is 1 and 18, 2 and 9, 3 and 6. So none of those add to give me 8. So factoring is not going to work here. So I can't find my roots. That tells me that my roots are probably not going to be nice integers or rational numbers. Another thing I can do is I could complete the square, so that I could get this into vertex form and find the vertex, and then I could plug some numbers in. But the one thing you need to make sure you always take out of this when it's in standard form is the y-intercept is going to be 9. Because if we plug 0 in for x, the y-intercept will be 9. So that right there gives you one of your ordered pairs of the 5. So 0, 9, my y-intercept is 9. That is always one of the first things I look for. First I look for roots, then I look for the y-intercept, then I'll put it in vertex form or graphing form and graph the vertex and go from there. So if I put that in vertex form, remember you group the first 2 terms. I'm going to bring out the 2. When I bring out the 2, I have x squared minus 4x. I leave a little space. I have the plus 9. And then half of 4 is 2, and 2 squared is 4. So I add 4 here. What I've really done is I've added 8. So over here, I'm going to subtract 8. And then I'll simplify that. So I've got f of x equals 2 times x minus 2 squared plus 1. So that means my vertex for this one is 2, 1. So my vertex is over here at 2, 1. I know my y-intercept is here at 0, 9. So if this is the vertex, I also know that my axis of symmetry goes through the vertex. So if my vertex is 2, 1, my axis of symmetry is x equals 2. That might be something that they ask you for. So x equals 2 is my axis of symmetry. I can use symmetry to get a point on the other side of the parabola. At 0, 9 we have a point. It's 2 from the axis of symmetry. So 2 on the other side would be at 4, 9. So we've got 3 points now on our parabola. We just need 2 more. And so to get my other point, I'm just going to pick a number that is close to x equals 2. I'm just going to pick x equals 1 because that's easy to plug in. So I'm going to plug in. Now you could plug into the original or you could plug into vertex form. I tend to think vertex form is easier, but you may not. If you want to plug into the original, that's fine. And remember, you can use Desmos or your calculator to do that. You don't have to do it in your head. So if I plug 1 in, 1 minus 2 is -1. -1 squared is 1. 1 times 2 is 2. And 2 plus 1 is 3. So when I pick 1, I end up with the ordered pair 1, 3. So 1, 3 is on there. And then I can use symmetry. That's 1 from the axis of symmetry. So 1 on the other side is there. And here is my parabola. One thing that I didn't mention is up here, your 2 was positive. So we know it's going to open up. And since you have a whole number in front, a number that is greater, that the absolute value of it is greater than 1, you know your graph is a little bit more narrow than the parent function would have been. Sometimes students see a problem like this and they get upset because they think it's different than the ones that we've had so far. It looks a little bit different at first, but really it's easier than the ones we've already done. If you think about this, it's in standard form right now, but it would be really easy to convert that to vertex form because in vertex form, isn't it x minus h squared? So since there's nothing here paired with the x, wouldn't that be understood to be x minus 0 squared minus 3? So just by adding that little 0 in there, that minus 0, we now have it in vertex form. So we don't have to complete the square with one like this. It's technically in standard form, and a little addition of a 0 there is going to make it in vertex form. So it's really very simple. So for this one, my vertex is 0, -3. So if that's my vertex, that means my axis of symmetry is x equals 0, or the y-axis. If I look here in standard form, it's x squared plus 0x minus 3. So my y-intercept is -3 here. Okay? And then there's one other thing that I want to talk to you about with parabolas, and that is my maximum and minimum value. Well, if we think about that, if we have a parabola that is going up, won't it have a minimum value wherever the vertex is? And if we're talking about a parabola that's concave down or opening down, wouldn't it have a maximum point that is the highest point, or that is the vertex there? So if they ask you to find the maximum or the minimum for one of your graphs, all you're going to do is look at the vertex. The maximum or minimum, depending on whether it opens up or down, is going to be the y-coordinate of your vertex. And you'll need to pay attention to the assignment you have in Delta Math as to whether they want you to express it as the vertex or just as the y-coordinate. Sometimes they ask it in different ways, so you just have to pay attention, maybe look at a sample to see how they want you to express the answers. So with this one opens up because there's a positive in front of the x squared term. Since it opens up, we know there is a minimum at 0, -3, or at the y value, -3. So that's another thing they might ask us for. So in this one, we have a minimum, and that minimum is at -3. So now if I graph this one, I know that my vertex is 0, -3. So I'm going to put that down here, 0, -3. This one would be also very easy to find the roots for. Because if you think about it, you can't factor that, but couldn't we just set that factor equal to 0? I'll do it right here. Instead of having y equals x squared plus minus 3 to find the roots, don't we set 0 equal to y, or y equal to 0? So 0 equals x squared minus 3. So if I were to factor, or if I were to solve that, I can't really factor it, it's not factorable. But if I were to solve that, I would have 3 equals x squared. And we know that with our work with equations so far, we can take the square root of both sides. So we have, since we put in the square root symbol, we have to include a plus and a minus in front. So we have plus minus the square root of 3. So that ends up being plus or minus the square root of 3 equals x. So that means my two roots are at positive square root of 3 and negative square root of 3. Now, I don't tend to draw those on my graph because they're decimals. I want whole number answers on my graph. So, but I do need to understand the square root of 3 is about 1.7. So it should cross the x-axis somewhere between 1 and 2. And it should cross over here somewhere between -1 and -2. And so that gives you a little bit of an understanding of how wide or narrow your graph should be. And it just makes the graphing a little bit easier, and it gives you some things to look at to make sure you're being accurate as you graph things. So if I go further with this, my axis of symmetry is at x equals 0, so it's right here. I know my function opens up, and here's another thing I know. I know that since a is 1, this one is not going to be any more wide or any more narrow than a normal parent function. And in a parent function, don't I know that when I start at the vertex, I go right 1 up 1, right 2 up 4, and I go left 1 up 1, and left 2 up 4? Since the thickness of this line is just like a parent function, I can go ahead and do that. So there is no doing an XY chart and plugging in to find the values. I know what this function is supposed to look like. So I've got my 5 points. Now I can graph this function. Another thing you need to understand here is, since this was in vertex form, I really could have gotten this graph without any of this information. I just want to make sure you're considering all these different areas before you just put a graph down, because they're going to ask you some questions about the information in the graph. It's very important that you understand what to put. So looking at this one, I want to graph it. I want to know what the vertex is. I want to know what the y-intercept is. I want to know what the roots are if I can find them, what the axis of symmetry is. So let me write all that down. I want to find the vertex, the y-intercept. Let's find whether it has a maximum or a minimum and identify what that is. Let's try to find the roots if that's possible. And let's try to find the axis of symmetry. Okay, well, looking at this, it's very similar to the last one, where we can rewrite that into vertex form very easily. That's -1/2 x minus 0 squared plus 2. It's in vertex form. So the vertex is 0, 2. The y-intercept we would find by looking at the standard form of the equation. When we plug 0 in for x, we get the y-intercept. So the y-intercept is 2. Maximum or minimum? Well, we have to consider, does this open up or down? Well, it opens down, so that means we're going to have a maximum, because if it opens down, it's in this direction, so we have a maximum. So that means if 0, 2 is the vertex, our maximum is equal to 2, the y-coordinate of that vertex. To find the roots, I could try to solve this, set it equal to 0 and solve. So I've got -1/2 x squared plus 2 equals 0. So if I move the 2 over, -1/2 x squared equals -2. If I divide by -1/2, and I would suggest you do that on a calculator, because a common mistake there is people divide -2 by -1/2 and they end up with 1, which is wrong. That means -2 divided by -1/2, which means we have to invert and multiply, so that ends up being a 4, not a 2. And then to finish that off, if I take the square root of both sides, I end up with x equals plus and minus. Remember, when we put in the square root, we have to put a plus minus in front, and that ends up being plus or minus 2. So my two roots are at 2 and negative 2. My axis of symmetry we still haven't found yet. Okay, so our roots are at plus and minus 2. Our axis of symmetry is the x equals the x coordinate of the vertex. So our axis of symmetry is x equals 0. So they might ask us all of this information in the same problem. And then they'll ask us to graph it. So if I just use this information to graph it, I know that my vertex is at 0, 2. That's right here. I know this is going down. I know this graph is going to be a little wider than the parent function. I know my roots are at 2 and negative 2. So right here and right here. And then my axis of symmetry is going down through here. And so I need 2 more points. It's probably going to be best if you just plug in another point. And to make the math easy, I'm going to plug in 1 because I think that would be an easy point to plug in for. So if I plug 1, I'm just going to plug it into the original. If I plug 1 into the original, 1 squared is 1. 1 times negative 1/2 is negative 1/2. And negative 1/2 plus 2 is 3/2, or 1 1/2. So if I were to graph that, I would go over to 1 up to 1 1/2. Now, here's a problem. If you're doing your assignment and they're asking you to graph it, how are you going to be able to put that in the exact location on the graph unless they're showing you exactly where it is? So maybe I should try to find points that would give me whole number answers instead of decimals. So putting 1 in here is going to make this a little bit more difficult. So think about that. What kind of numbers do I need to put in for x so that I will end up with a whole number answer? Why don't we say maybe some even numbers? Now, I don't want to put in 2 because I already got that value. So let's put in 4 and see what happens. 4 plugged into that is negative 6. So that gives us a nice whole number corner point value that we can use. So that would be 4 negative 6. Okay. So 4 negative 6 is here. And then I know that my axis of symmetry is the y-axis. I have it drawn there if you can see it. And so I'm going to use symmetry. 1, 2, 3. That's 4 from the axis. 1, 2, 3, 4 on the other side. Gives me the other point, or the 5th point that I'm looking for. And here's my parabola. And again, remember, you can do this graphing on Desmos. You do not have to feel like you have to put it on a piece of paper. It gets very complicated if you do this, but this is just to show you the general shape of what they look like. Putting them on Desmos is going to make it a lot easier for you. And you have enough training in that I think you can do that easily.